Hello everyone, this is Dr. Tithi Banerjee, Assistant Professor of Department of Civil Engineering from Swami Vivekananda Institute of Science and Technology. So today I'll be delivering lecture on the subject coastal hydraulics and sediment transport, and the topic of discussion is transformation and its measurements. So class, in the previous lectures I have already delivered a detailed discussion on how wave generates and how wave propagates. So in this class, I will be discussing in details regarding the wave transformation and its measurements. So let's start the class. So as we all know that in case of wave generation, the water doesn't travel, only the energy transmits from one point to another, and because of the energy transmission, the wave generates. So, wave motion typically involves a packet of waves encompassing a finite number of wave cycles. Okay, so a wavelength, I will be discussing regarding different parameters of a wave. So information in a wave only can be transmitted by starting, stopping, or modulating the amplitude of a wave train, which is equivalent to forming a wave packet. So what does it mean? That when the wave propagates, a wavelength is the distance over which the wave shape repeats. So wave generally propagates in the pattern of sinuous curve, and a wavelength is the distance over which the wave shape repeats. Okay, so one complete wave propagation cycle is equal to one completion of wavelength, right? So what is the wavelength? Wavelength is the horizontal distance between two crests. So first of all, we need to know that what is wave crest and what is wave trough. So crest is the highest point that is shown in the figure. That crest is the highest point and trough is the lowest point of the wave. So in the figure, you can see that the figure is representing, you see the wave propagation, and the figure is representing that the energy which is derived from the frictional force of the interplay of water and air, the energy transmits from one point to another, and that's why the wave is propagating. So the lowest point is known as the trough, and the highest point of the wave is known as the crest. And the vertical distance between the wave crest and trough is known as wave height or wave amplitude. So the vertical distance between the wave trough and wave crest is known as the amplitude or wave height. Now, wave steepness is the ratio of wave height and wave length, right? So, when the steepness exceeds a certain limit, then the wave breaks. Why? Because the height of the crest increases in that way that the wave cannot propagate anymore and the wave used to break. So breaking waves releases kinetic energy to the shore, and that's why swash and back forth of wave is generated. Right? So so that means that wavelength is the length of a sine wave from 0 to 2 pi. It represents a complete cycle of wave propagation. So 0 to 2 pi represents a complete cycle of wave propagation. Now, what is refraction? Where in the figure we see that refraction is the process when waves approach shallow water, their speed decreases. Why? Because of the frictional force. Okay, because in the shallow water wave is getting ample amount of obstruction, and that's why the speed decreases. This phenomenon is known as wave refraction, and parts of the wave in shallower water slow more, causing bending. So why wave is bending? Because near the shoreline, the wave is getting enormous amount of obstruction, and that's why higher frictional, higher intense, that's why higher intensity in the frictional force increases along the shoreline because of the more obstruction, and that's why the wave causes bending, and after the bending the waves break down, right? So what is shoaling? Shoaling is the phenomenon where wave height increases as waves move into the shallower depth. So when the wave height increases, what I have told, the wave breaks. When the crest height increases in a certain limit, then the wave breaks. So this phenomenon is called shoaling. So shoaling can lead to higher breaking near the shore. So what is the swash and backwash process? When the wave propagates in the shallower depth, then it is coming nearer to the shore, and then swash of wave is occurred. And after getting heated by the shore or any kind of coastal structures, again the wave propagates towards the deeper area of the sea away from the shoreline, and this back process is known as the backwash. Okay, so these are the different phenomena related to wave transformation. So now we will learn that why researchers need wave measurements. Waves travel water often very long distance and can contain high levels of energy. These qualities alone mean that they have the potential to impact many facets of human life. Wave can affect the ability of boats to navigate or of people to make use of shorelines. Right? So without wave propagation, any boat or any kind of sea transport cannot be travel, because the all the mode of transport of sea travels because of the wave propagation. Now wave can even destroy settlements on the water also, because we all know that in the shallower depths waves the wave heights reach in a certain limit and wave breaks, and that's why it can destroy the settlement on the water. There are also critical aspects, yet less apparent. Uh, there are also critical aspects where, with the wave breaks, so we need to, as a civil engineer, we need to construct coastal structures like seawalls, grants, and jetties. These are the all coastal structures we design to prevent coastal erosion when wave breaks. And wave breaks in the shallower depth because the wave crest reaches a certain limit of height. So to prevent coastal erosion, we need to construct. To prevent coastal erosion, to prevent the human or animal habitat in and around coastal area or shoreline, prevention of coastal erosion is very essential, and for that design of coastal structure has been implemented, and for this we need to know the wave motion, and we need to know the intensity of the wave at which the wave is usually propagating. Now there are several tools for assessment of wave, that are buoys, wave gauges, radar. These are the important tools which helps us to measure or to assess wave intensity or wave propagation. These instruments generally record height, period, and direction. Data is vital for coastal engineering and navigation safety. Okay, the engineers use statistical models to predict wave behavior. In the left side of the slide, you can see that several wave propagation models are represented here. So these frequency curves are generated through the radar or buoys, and the civil engineers or the coastal engineers used to know that how the wave is propagating through this frequency curve. So higher the amplitude of the frequency curve, the intensity of the wave is higher, right? So these are the frequency curves which are generated by the radars, wave gauges, or the tools beyond, or the bias, which helps us to understand the propagation and intensity of waves, right? So now traditionally in the left side we are seeing that a photograph has been given of radar and bias. So traditionally, radar has been the method used to measure surface currents and waves when coverage of large surface is the goal. A broad range of technologies fit into the categories such as shore-based high-frequency radar arrays, microwave, navigational radars, and aircraft or satellite-based synthetic aperture radar. So, what does radar do? Radars helps us to generate the frequency curve, and by studying or interpreting the frequency curve we can easily interpret what is the intensity of the wave. So I can conclude that to calculate wave data a system must achieve several aims. It must analyze and report domain wave height and wave period statistics. So these data which are getting generated by usage of this radar. So the spectral analysis of the wave domain represented by the statistical curve or the sinuous curve which are generating by the radars or the bias, this helps us to navigate a vast domain of wave propagation. Okay, so that's all for this class. In the next class, we will be discussing regarding tidal waves and tidal force. Okay, thank you. These are the references. Okay, we'll see you in the next class.